So, welcome to the Patterns and Practices event. This is what we call a taste of leap. What is this leap you speak of? Well, it's that thing, and you've already got some information about it. It's a thing that we've been running in Norway for 10 years. It's a program to go basically travel to Redmond and hang out with people like Masashi here and Francis and others from the product groups and learn more about architecture, learn more about how to actually do things in the cloud, for instance, and other people from other product groups. And it's a 5-day program. And yeah, also people from the local sub, like Johnny and Mikko here, will be there and kind of help you out and, well, socialize with Microsoft people and, yeah, whatnot. So this year we're taking it to the Nordics because of, well, we're a reorganized Microsoft. We're now a Nordic thing rather than individual countries. So these are now my fine colleagues. So we're working together on this. So, who am I? Well, I'm the local janitor called Einar. I work together with Janni and Mikko and the OCP, Nordic ISV. There's a lot of letters there. And it means one commercial partner and independent software vendor. Microsoft terms. Means, do you build off-the-shelf software? How many here builds off-the-shelf software and sells it? 2 guys. I am in trouble. Oh, rest are salespeople. Okay. You're supposed to go to the next store? No. Okay. Okay. Well, what we basically do is just we advise on architecture in the cloud. That's kind of what we do. So my background is a developer and architect for way too many years, 20 plus. And yeah. That's a little bit about me. So, this is the agenda for today. We hope we might not make all the time slots perfect like that. It looks better on the screen than in real life. So, we're going to have lunch at 11:30ish, and then we also have a small break at 1ish. And we try to end the day at 3 o'clock. So, our industry is all about fashion, right? We're in the fashion industry. Did you know that? Really? We are. Because it's all about the Node.js package of the week, right? It's all about, yeah, that's going to solve all my issues. It's going to be like you pick that NuGet package and you're good to go. And there's a new one every week, right? That you have to learn. And every now and then you get these interesting failures, right? Some of them are just, whoa, what the hell? So that can't be right, right? It's also a lot about these buzzwords. Our industry is filled with buzzwords. And big data. How big is big data? It must be massive. Is there something called massive data? This is kind of what we do. We have all these things. I probably forgot. Yeah, I didn't put in microservices, which is one of the latest buzzes, right? And kind of fogs up your mind a little, right? Because we hear all these things, and we don't necessarily know exactly what they mean. And I think that is a bit of a problem, and that's why we're kind of a little bit here today to actually clarify some of that, right? So, and it's kind of weird, especially when everyone knows that making software is like having sex. Got your attention? It's 10 seconds of pleasure and 18 years of support, right? That's what software is all about, because the initial development cycle is a tiny piece of what we actually do. When we deliver, it's all about the maintenance. It's all about the maintenance of the product. And that's the period that takes the longest. So we have to kind of build software in a good way to make that period good, so that we have a good maintenance experience as developers. And that's also where kind of these patterns and practices can really help us out to make that period a better period, right? So architecture is definitely part of that, to make that kind of go well. But what is architecture? Architecture to me starts with at least, well, you have servers, you have hardware in your architecture. You definitely have code, so you need kind of a systems architecture on top of whatever infrastructure architecture you have to run on that infrastructure. Then you have connectivity, so you need some kind of network architecture around this, right? And also part of this, and I would argue probably one of the most important things, is how you actually deal with the process surrounding all this. How do you actually deliver that software? How do we actually do all the, like when we talk about continuous delivery, DevOps, all these kind of things, having a supporting process to make your architecture fit well. And to me, I think it's super important to actually have very, very clear goals when it comes to architecture. It should be a recipe that makes it super easy to do everything right and super hard to do it wrong. That should be a very, very clear goal for us when we set out making software. We should also think about all the stakeholders of the project. Anyone here loves the IT department? Show of hands. Silence. None, right? But we should actually include them. They're real stakeholders, right? That we should talk to because they have requirements. They're going to operate the stuff that we make. So they should be definitely included. Maybe we can make small little pieces in our software that makes their lives easier. And we should make our software change resistant. The promise of Agile, well, we can't promise Agile if our software isn't capable of delivering Agile. If Agile is saying we should change and change often, fail often, fail fast kind of thing, well, if our software is not capable of doing that, well, we're kind of stuck. So we should make our software capable of dealing with change. Super important. So Winston Churchill invented Agile, in case you didn't pay attention. Did you know that? No. But I think this is a perfect statement, because that's the... I love it. So it's all about actually changing as often as you can, and actually making, if you want to make the perfect thing, you actually have to do that, right? And really respond to market changes in a good way. So, walking down history a little bit, we all kind of started by building, like if you look back 30, 40, 50 years ago, that's where we came from. We built these solutions where it was all about forms over data, right? That's how we digitalized the first round of computers. We took whatever form they had, we put it into the computer and made it look exactly the same as the paper one. And it was all terminals, and kind of the architecture of that time, slightly simplified, looked a little bit like this. You had a mainframe. You connected to with your terminal, and the terminal was a dumb terminal just reflecting the display, right? That the mainframe was serving. And you were basically just sending display back and forth, right? We then, at a later stage, got more richer client, more capable clients, enabling us to connect in a very different way, having more logic on the client side. And we came up with things like remote procedure calls that enabled us to do this. We had the Corbus of the world and RPC and Microsoft RPC and things like that. So, evolving from that, something came out of Redmond. Anyone played with DCOM? Anyone like decom? Nah, that's not good. Pretty bad stuff. But the idea of it is good, or sound. The idea of having basically objects that you don't know where live, right? And you just create instances and they can live anywhere. Sounds like a cool idea, right? Hard to get it right, yeah, but in the abstract. And we eventually got to the soap. We cleaned up everything with soap, right? At least we thought so. We came up with XML, we had XPath, we had all XML schema, we had all these kind of things. We even came up with XSLT. Powerful stuff, right? And Microsoft actually put C# into it. That was really good. C# into anything, even XSLT. So, but we came up with kind of a request response as well. We're starting to see that that is a good pattern for things. And we had .NET remoting in kind of almost the same time frame. Building a little bit upon the idea of decom and all that, but introducing more flexibility, especially at the transport level, where you can just basically have anything as a transport, be it HTTP, TCP, or whatever. And later, of course, WCF, kind of following up on that same idea. And what about this thing? Service-oriented architecture. Anyone love this? The BizTalk of the world? Yeah? That was a good time, yeah, for consultancies. So the promise of SOA was good though, because it said, let's go and build decoupled systems, right? Decouple our software, make smaller, like make bigger problems smaller. It's a good idea. It was all oriented around messaging, and we had kind of these well-defined formats. You had schemas, you had all these kind of things, trying to kind of make it possible to compose things back together. So in its abstract, again, pretty good. So where does that leave us kind of today? Well, we've swapped out XML for JSON. We've swapped out XPath with JamesPath. We've swapped out our service descriptors with Swagger and things like this. And it's all JSON-based. Still the HTTP kind of transport, and it's a request-response pattern. This seems to be a recurring thing that we're coming back to. So this is typically a modern web app. And how you would interact with it is a user comes in and, well, take a to-do list like this, goes and say, let's edit that. We send off a request to the server, go to the database, get some data, translate it into JSON, sends it to the client, and shows it in a form. And you start editing things, you assign it to someone, you mark it as complete maybe, and you go save, and we send a JSON back to the server and back to the database, and we're done. That's pretty much what we tend to do for applications today. And that leaves us kind of with the N-tier architecture. We have a front end, we have a back end, and we have a database. That's what we tend to work with. And looking closer at this place and patterns for dealing with something like scale or resilience or, yeah, failover situations and things like that, we tend to take like the back end part and scale it out. We have multiple instances running with that application on it. That makes it possible for us to scale. So let's say for load purposes, we could scale this out. And also, as I mentioned, in a load balancing situation with failover, makes perfect sense, right? We would just round robin around these servers and deal with the load as well. And you reach a point where, well, we have enough users to actually justify scaling out even further, and all of a sudden we have a bunch of servers running this application. And now we're kind of, everything is pointing to the one bottleneck there. So we kind of throw money at that, buying licenses, because, well, licenses in this world is tied to the core, right? How many cores are you running? I'm running one, and now I have two. I pay twice the price. That's awesome. So I scale by making that bigger, and I throw even more money at that bonfire and scale as big as I can. Now we're at the limits of, well, the speed of light can only travel as fast as it can, so we cannot scale that up. And we tend to kind of scale it down again, and instead introduce these replicas, right? We scale out, use the same pattern as we had, scale it out, and we use these replicas for read. We write one place, replicate out, and read. That way we can kind of balance out the traffic. And then we throw in caching when we reach a certain point, right? We solve the next level by caching. And that's a massive thing we just did there. Super hard to actually deal with. Ask anyone in Norway. There was a headline a few years back we have a system for registering tax returns. You probably have the same thing, right? You go into this place, you register a tax return, and they hit the scaling issue, right? And this one dev at the back, hey, let's introduce caching because, well, it's crashing right now, so let's fix it by caching. So they did. Next day, newspaper articles read, Kenneth 36. Everyone was looking at Kenneth's tax return because of caching. So 1 million Norwegians logged in, and I'm not Kenneth. What? Well, he makes that much. Okay, interesting. So caching is a hard problem because it's what is the actual key that you should be using, which is what they screwed up on, and when do you invalidate that cache? Well, it could be 2 minutes, and the next guy says, "Nah, my stuff, 4 minutes." So it can be quite arbitrary. Well, you also introduce into this, which is quite interesting, because the database has been, at this point, kind of guaranteeing asset. Everything that you put in can be read immediately. Well, we just introduced eventual consistency. And we don't know when it's consistent. We have no control. So the complexity in this is actually quite big. So that monolith should be broken up into something smaller. And again, it's one of these buzzwords. So what does that mean? What does this mean, break it up into these smaller pieces? And how big is that piece? What is the size of microservice? Why can't I go to nano or pico, or how far down can I go? Right? We need to figure out what's the size. Is it this big? This big? It's probably more like this, right? So, now for something completely different. Leave you hanging. Remember when, back in the days, when Linux was a form of cancer? I think this is the perfect audience. Right? We've cured it. We've cured us. Right? So there was also at this time this awesome thing. It's really that was the future, right? But we also at this time we did something good. We created this team in Microsoft called Patterns and Practices. And their whole purpose was to, well, find these patterns, proven practices for predictable results. That actually is exactly what they do. This is what they do. So they came up with things like the enterprise application blocks, Prism, the IOC implementation, the Unity thing, and all that stuff, and documenting everything so that, well, developers can take a look at it and find proven practices and apply them for themselves.